Guys, good morning. Last class of the semester, I'll take half hour to kind of go through the final exam review as to what you should be preparing. And then I'll do delegates and operator overloading, method overloading, which you've already done, and a little more stuff in classes in C Sharp, right? So that's what I would like to do more. I'm not sure like if Rich has done it, but whatever it is, like I thought I would just do more of it because this was an extra class and the other section is not taking it. So on Blackboard are all your marks till date except the final exam, right? So all marks are up to date on Blackboard. The only thing I have to do is give them some weightage. So now that I can do another quiz because of the other section being behind schedule, you did 2 quizzes, which I'm putting at 5% each is what I'm thinking, right? And then the three assignments you did before, I'll kind of distribute them. Whatever, depending upon the assignment, I'll kind of distribute my rest of the marks. Okay, so I'll do that during the holidays. I'll put the weight during the holidays, but everything is marked and you have a fairly good idea of where you stand. So now about the final exam review. After the strike, we've kind of worked on. You were a little ahead, but what we worked on, what I worked on with the other section of the midterm exam is one, lists, right? So I've done lists with them in more detail. So just not using it in the GUI, but also in more detail, methods of the list and so on, add and remove and so on, which you've also done. 2, the second major thing we've done is the files, right? We've learned how to read from files, how to write to files, what are the various modes in which it can be opened, the various try catches you need, the various exceptions that can be thrown, and so on. So what I'm planning to do is I'm planning to basically, so definitely you must know how to work with lists. So when I say list, I mean the list data structure from the language, and I also mean lists from the GUI, right? So both. So with the list and also the, it's also called the list, right? The list box. And I'll also say combo boxes, though I've already done combo box, so I may not even ask it. Right, so that's the first thing you definitely need to know. So how to create a list? If you remember, we can create lists of any type. You can create lists of integers, reals, so on, but also of your own objects. And we learned how to do that last week with list of products, if you remember. Definitely, you should know how to create your own classes. Whatever I've done last week is what I'll kind of stick to. What we do today is entirely up to you. If you want to use it, sure. If you don't want to use it, it's not compulsory at all because the other section won't do it. So how to work with classes, so how to create classes and objects, of course. And keep in mind, validation still holds. And I had done this again last week with you. I had created a validator class in which I had created all my validation methods. So that that's the main advantage of classes, right? You put your code in one class. Each class is capable of doing a job, and each method in it is capable of doing a job. So how to validate classes? How to validate data using class? And I'll kind of give you a hint as to what we did. Right, so definitely. So I'll see that you know how to do that. And of course, you'll be able to use all your previous code, anything that we've done in class, all your assignments or whatever. So it shouldn't be kind of tough to reproduce it or to extend it, right? But keep in mind, when you copy and paste, there are things you need to change, right? There may be messages you need to change. I still see messages like quantity cannot be negative and price should be greater than 0 kind of stuff in your exams too. Okay, so, and then of course, how to work with files. That's very important. Now, I have worked with text files in class. I have given you an example of binary file. I have, like I did. It was already in code. Today, I'll kind of also show you that it works so that I can show you it works. So just because the other section, I wasn't able to show them, but we were able to do text. I'll kind of say text files and binary files. So I kind of leave it to the student to kind of say, oh, whatever file you need to use. So I won't restrict it, oh, you have to use a binary file or you have to use text. I'll just leave it open, right? Now, when I say how to work with files, text and binary files, definitely you should be able to read from files. And then, you know what I'll do? I'll kind of Strange, why can't I do that? Maybe now, remove it from here and then do it now. Okay. So as I said, since I haven't kind of done it with the other section, though I of course gave an example, I'll kind of keep it open. And I'll do binary files with you today, right? Just so that you have an idea. So you should definitely be able to read from files. And when I say read from files, you should know how you can read in sense of read data at a time, read line at a time, and so on, okay? And all exception handling has to be done. So now, if you remember, last week I had shown you that when you open files, when you read from files, there was a long list of exceptions associated with each method. I'm not expecting you to write a catch for every exception, but I would like to see a try catch, maybe with IO exception, with the highermost, so that at least I know you can do it. And of course, that it is caught if something happens, okay? So you should know that when you open files, and again, when I say how to work with files, you also keep in mind that I'm talking also about the file stream reader, the file writer class, and so on, everything. They're all included, right? So all classes are included. Again, depending upon whether you're using text files or binary files, but stream reader, stream writer, file stream reader, everything has to be done as I've done it in class. Okay, so when you read from files, there are a few options. We've done read lines, but that doesn't mean you shouldn't know how to read. You should be able to read from files using all methods. What I'm thinking is that I'll create a text file for you. And again, if you don't want to use mine and use binary, then you'll have to create it yourself in your code. So anyway, so I'll create a file, and like last week we had each record had code, description, and price. So I'll kind of create a record, which of course will be different, but may have something like maybe student number and marks. You know what I mean? So by each record will have more than one piece of data. Okay. So when I say how to work with files, including text and binary files, I can kind of mention record, or I mean, we call it record, but you can call it line or whatever. Right. So what I mean by saying is you could have something like you did in your product class. Okay. So your each line will have some data. I'll give it to you. I mean, I'm not expecting you to do everything in 3 hours. So I'll do whatever I can, and then I'll leave the rest to you. You know what I mean? So I know it has to be done in 3 hours. So you should be able to read from files using any method. It could be read line. If you're using binary files, it's up to you. Read decimal, read int, whatever you like. Okay. And when I give you the file, I'll make something in a record. It will just not be something simple. You should be able to read from files. You should be able definitely to write data to file. And again, you should be able to write it using write line, write, all methods. Okay. So, and again, when you say how to work with the list and also with list box and combo box, keep in mind that you should be able to display data on the screen and delete, like it comes on the screen, and you should be able to display data on the screen. So I'll kind of add it here. And again, we did an example last week. I'm going to extend that example today, so you'll get it again today, right? So display data on the screen. So using a list box, for example. I mean, that would be one way of doing it, but it depends how you want to do it. But you can do it whatever way you like. But I'll kind of think of list box. Then of course you should be able to do some computation on your data. It could be as simple as, maybe calculating average, finding the highest, finding the lowest, and so on. So some kind of logic, I'll kind of. So you're basically reading from a file. Your file has some records. Each record has some piece of data. So maybe student records. You know what I mean? Student records. And then you read from it, or temperature data, whatever it is. Temperature on Monday or Tuesday. Some kind of data. You read from it. You show it on the screen so that I can see what was in the file. And then you'll do something like the average of marks is, or the maximum mark in the classes, or the minimum mark in the classes, and so on and so on. Right? So that's basically what I'm kind of thinking for the final exam. Since since 75% of the class, or around 70% of the class, the whole two sections have kind of voted for online, for hands-on exam, I'll create a hands-on exam. So I'll keep this in mind. What I've given you is what I'll keep in mind when I'm grading it. So when I say perform some computation on data, I mean, definitely it could be anything. I can't say what, because it's just a computation. So you should know how to use for loops or if statements and so on and so forth. That's what you'll have. I mean, it's expected. So anything that you've covered from day one to today, definitely you should know about it. You know what I mean? You can't say, oh, I don't know the syntax of for. You can't say that. I didn't do it after this strike. That doesn't work. So when I say how to work with list, I mean the list data structure. I mean, it could be any list. I can say any collection. Let's say with collection classes, maybe that way I'm safe. When I say collection classes, it could be arrays, it could be list, it could be array list, and so on and so forth. Just trying to give you an idea. It's not that I'll ask you everything. It just kind of gives me a little more flexibility. Right? So you should know how to use the list box and combo boxes, because as soon as you start using a collection, these kind of come into picture, which doesn't mean that you shouldn't know how to use buttons and so on. But I mean, this is something that you will have to do when you're working with collections, right? So kind of that's what I'm thinking. So you should be able to read from a file. You should be able to write to a file if things change. You should be able to take the data, compute something on it. As I said, some kind of calculations using loops and if statements and so on, and display the result on the screen, right? So definitely interface will be there, but it won't be like huge interface, not very big, but definitely small things about interface should be centered and so on and so forth will automatically go. I mean, you've been doing it now. This is your 10th lesson you're doing today, so you've been doing it all over and over again. Unfortunately, not really doing it after the strike by hand, because we didn't have any assignments as per se, but at least if you were in class and you were listening to me or doing it with me when I was doing, you still are doing what we've been doing from day one, right? So that's what I'm thinking, and that's the basis on which I'll kind of keep it. So I'll post this on Blackboard for you so that you have it, but I mean, just to give you an idea that this is what I'm aiming at. And I'll post it on Blackboard also. If I add something to it after, so you just double check when I say it's been posted. Okay. Anything else you have in mind that you've done new, or something that I have kind of forgotten? Anything that comes to your mind? This is what comes to my mind from what we've done after the midterm, right? So these are the new topics that we've done after the midterm. The old ones definitely stay. Like as I said, you can say, oh, you didn't tell us that we had to know buttons, and I mean, those are kind of automatically done, right? So my aim is to, just because you guys like more hands-on, and it makes sense since you're programmers, and it's always that you'll have your resources. If need be, depending upon the question I write, if need be that you have to access the MSDN website for something, I'll allow you to do that, right? So I'll keep that in mind. If there is a class or a method that you just want to look at, really doesn't make a difference.
Is the whole thing going to be from scratch, or are you going to give us some template?
I think it will be a scratch, because I would like you to create a list box and buttons, but it won't be very heavy. You know what I mean?
Do you think maybe you could build that part of it, and then like you have the combo box, and
because you haven't done list boxes, and I would like you to use it, and I want to leave it to you. However you make your design, it won't be like big. I mean, all it would be what you did in your. It could be a list box. There could be a couple of buttons and a display box. That's it. It's not a big deal. If you want, I'll do it. I'll do it. Right? If it saves time. If I see that the other stuff will take more time, then I'll create it for you. If I see that creating the interface and what I've asked is doable in 3 hours, I'll let you go. Right? Yeah, at this point of time, the interface, you don't want to waste your time in interface. I understand that. Yeah, because it's an interface.
It's stuff we've done. Like,
yeah, you've done it 3-4 times. Yeah. The only thing you haven't done is a list box, but yeah, things like centering it, which people are still not doing, believe it or not. Like students still don't do it. But anyway, that's not a big deal. So maybe I just kind of create an empty form and do these things and put the buttons and then say, now you can add whatever you want. Yeah, I can do that. I'll do that, just so that all those small things you don't have to bother, and it saves me time also from morning, to be very truthful.
When I did the last test, like, I focused on solving the problems first, and then going back and trying to remember, like, trying to check off the list of all the things I have to do.
But that was your midterm, so it was expected that you would be asked those small things, not small
But
things.
I'm just saying, like,
I understand. I definitely. So you know what? I'll kind of make a rough template where I can take care of centering and all that stuff, which should be by default. And then if anything needs to be, new controls need to be added, then I'll say you. Okay, I'll do that. That way, at least you're not bothering and putting your mind there, right? But definitely, this is the new. These are the new topics we've covered after the midterm, right? And that is what the test will be focused. Plus, of course, all that you've done in the language. What we are doing today is an extension of the project I was doing last week. So if you like, I've placed the final project on Blackboard also, because it will be helpful when you prep for your exam. So students ask me, so I put it because on GitHub, I think it doesn't come like a project, like a zip file. You just have to copy and paste or whatever. So what I've done is, last week, whatever we worked on, I have zipped it up and it's on Blackboard. So if you don't have it from last week, you can take that, and I'm going to add new stuff to it today. Okay, so that's the aim today. So as I said, I would like to introduce you to delegates, which are basically pointers to functions coming from old terminology. We used to use them in the C language, and now they're back again. They were gone. I've never seen them in object-oriented languages. Like, they were gone from Java. I don't know why, but whatever the reason was. So they were old concepts are again coming back. They're again being introduced in object-oriented programming. So C# has it. So I'll show you how to work with it. And of course, operator overloading and so on. You've heard many times about it. Java also allows it. I'll just show you how to do it. Right? So that's the aim of what I want to do today. So as I said, if you can pick up the example, so I'll put this on Blackboard, and if I can remember anything else, I'll add to it. But as I said, the main emphasis is working with files. And again, you should know all modes in which it can be opened or whatever. You'll have to decide, oh, am I only reading from it? Am I reading and writing to it? And so on and so forth. Right? So all that stuff you'll have to think about that time. So I'll keep it, give you part of the interface. I won't give it 100%, but I'll give you part of the interface so that you don't have to put in time in that. I can do that. I'll put that, keep it in mind. I still have to make it because this is because of how we had to change the course. So I still have to make my exam, but I'll keep that in mind. And when I make it, if I find anything that is different or I've missed here, I'll add it. I'll let you know that. Keep your mind open for that. Right? That's what I'm thinking. I've kind of made up the question in my head already. I just have to put it on paper. So keeping that in mind, I've kind of listed things that are in my mind of how I'll work with this. Okay. So today, as I said, so this is coming from last week. I'll refresh your memory. So today, instead of using the text files, I'll use binary files today. I'd already given it to you. Oh, there are no try catches here, so I should have picked up from Blackboard. I added my try catch before I put it on Blackboard, but this is your example that I've picked up. So you know what I'll do is, maybe just because try catch is already, it's not in the binary file anyway. So today I'll also show you how to work with binary files. So let me refresh your memories as to what we were doing and then add to it. So last week, so this is all kind of I'm expecting from you also. It won't be very big at all. But anyway, so last time, this is what we were doing. It was an inventory being saved in a file. So you had inventory, each product had 3 parts to it. We learned how to create classes last week. So we had a product class with instance variables or fields, code, description, and price. We talked about self-body properties. We talked about self-implementing properties and methods and lambda operators and so on. And as I said, we'll do more today. Right, so every product has 3 attributes, as you call it in Java, and here they're just called fields. But every instance of product will have 3 instance variables: the code, the description, and the price. Right, and our aim is that when the project starts, all your inventory is shown here on the list. Right, so it kind of comes here. You'll see what if there are more. You will see automatically if the contents of a list box are more, it adds scroll bars to it. You can always add scroll bars horizontally also and vertically also. Horizontally, I would avoid. It's very untidy, but if it's really big, it's something else. But otherwise, avoid horizontal scroll bars. Verticals you may need sometimes. You can create a form that big. will say, oh, vertical bars are okay. That's perfectly fine, right? But list boxes can have scroll bars. I mean, it's obvious. You've seen them in normal quiz, right? So when the project starts, data is read from the file. All the inventory information is displayed here for the user. And that's what you're expected to do when something starts. I would like to see the contents of the file. Then you have two options. You can delete a particular product or you can add a new product. So the delete product is really simple. All the delete product does it, you choose something from the list box contents. And with this, you're also maintaining a list data structure. So whatever I'm seeing in the list box, which is only for display purposes, it is also being saved in a list of product objects. There is one-to-one correspondence between the two. If you remember last week, we were talking about sorting these. This sorting was not difficult at all, but looking for it. But it's not that easy because, and I've done so many things on it that I've kind of given up, but of course there will be a solution. But keep in mind that you can just also not only sort, sorting is easy, but you just can sort a list if the list has record structure. So our list, every list element had 3 values inside it. There was a code, there was a description, and there was a price. So you just can't say list.sort and it will sort it because it's not a singular field, it's a group of fields. So I can sort the list, but for that I'll have to take out the code, which we can say from get code. We have a get method, create a new list, sort that list, and then I have to match it with this list. Now the problem here is this is sorted perfectly fine. I get a position where I am. But then once I get that position, I'm interested in the code of that position. So to extract the code from a string, before you did a split, now you'll have to kind of again split it till the first, you want the first one. So you get the name code from here, you create a list of only codes, then you match the codes, then it is easy, and then you come back and do it. But you cannot sort a list of records. I'm calling it records, right? Because record has more than one data item in it. So each product in your list, the list was a list of product objects. So each product had a code, a description, and a price. You simply cannot say products.sort. It won't do it. You get a runtime error. And it makes sense, right? What are you sorting on? Are you sorting on code? Are you sorting on description? Or are you sorting on price? Then I tried to look up if I could do it on a particular field. There wasn't any method. So the only possibility is that you extract the code by saying get code, put it in a new list, sort that list of codes from here, pick up the code that the user has chosen. Again, remember, this is a whole record. It's only for display purposes. So you'll have to pick up that selected item, pick up the first 4 because we know the code is first 4. But if not, there was a tab in between. You can just find that till the tab, take the code, find the position, and remove it from the list. But you cannot sort a list of product objects by just saying products.sort. It cannot be done. Okay, which we thought was easy, right? We thought we'll sort this, and it will work. It doesn't. Anyway, so this is what you did last week. And when you did an add product, a new form came up. And in the new form, you validated data. So we learned how to also create a validator class, which is neat, right? So the class now is self-contained. You could just pick up this class and put it in any project that you required. You could add new methods into it, but you have to remember that you call them in sequence. So I say is not blank, is a decimal, and then is within range when I'm checking price, for example, right? Or in the validator, every method is checking everything else, which is kind of an overkill. So is decimal is also checking is present. Is within range is checking is present and is decimal before it does it. So you could do it that way if you like. I think it's an overkill if you're writing the, but on the other hand, you could say, oh, I want to write a generic class. Doesn't matter. I don't want to tell the user that you have to say is present, whatever is decimal and is within range. So to avoid that, in here you can simply call is present and is decimal first before you do the is within range. In the is decimal, you should first call the is present, and if it is present, then you must check it as a decimal. Which is fine. Like, it's not a big deal at all. It's just calling and adding. So before even I start doing this, I call the is present here. If it returns a true, I do the rest of the job, else I return a false. So you should know how to write the validator class and add new methods to it. I wanted a decimal, I wrote an is decimal. If you're going to validate an integer, like marks of a student, temperature, which is an integer, you should know how to write is. Okay. I've written is within range and my inputs are decimal numbers. If I'm checking that if integers are within range, these will be integers and not decimals. So again, whatever I've done in class, you will be expected to kind of extend it or use it to do what I ask you in the exam. Okay. Okay, so the validator class was also ready and the product class was also ready. Today, as I said, I want to show you a few more things in C# which are really neat. Definitely in class definitions. They're really neat, like delegates and operator overloading and so on, which again, I don't know if you've done in your advanced Java also or with visuals. Right, so what I'm going to do today, I'm going to create a new class. Right, so here notice how my product class or my form main or whatever were using normal lists. I want to replace those lists, this list, with my own list today. So I'll define a user-defined list. In that list, I will, of course, it's kind of not extending, but it is taking its properties from the list of the C# library. But I'll add the methods that I want in that list, and I can use what is already available and add my own new methods, right? And then show you operator overloading and method overloading and delegates and event handling and so on. So instead of using the list as it stands, of course it is a rich collection. There's no doubt about it. There are many methods and it's a rich collection. But you can always create your own custom list in which you say, this is how my list will be. So you will take the properties of the list class. I'm not extending it. Extending always says take everything and add more. I'll kind of use it and create my own list class. So I'm going to create a class today, and just to make it different from list, I'll call it product list. And it will take the properties of the list class, whatever it needs, add the extra that it requires, and I'll show you how I'm creating my own list. So it's basically a user-defined list that takes from the list class of the C# library what is required, so that I don't have to deal with everything there, just my own one. That's how you write applications, right? You take what you need and then you work with it. Okay, so that's the aim today. So I'm going to add a new class. So first I'll add it and then I'll make changes. So I'm going to add a new class today. And again, because I've done C and I come from the old era of function pointers to functions, today we call them methods. And instead of pointers, we call them references. I'll try to explain how they're used or their importance. But I mean, it could be a new concept for you. Okay, so I'll call it product list. And of course, the .cs. Right, so I'm going to create a new class in my project. I'm just calling it, you could call it whatever you like. This just makes sense to me, product list. The same conventions follow. We follow Pascal naming conventions in class names and also in method names in C#. So let's add it. So as soon as you add it, you will see that you get a template. And because C# doesn't put public by default in front of it, I like to put public. Then I can use it in different classes inside the project. Okay. Otherwise, by default, I think it's private if I'm not mistaken. I thought it would be public, but that's not how C# works. It's not public by default. Okay, so as always, a class is nothing but encapsulates data, what it needs, and what can it do. So how do I look and what can I do? So encapsulation is your principle of class definitions, and I'll follow that too. Okay, so the fields that I will need. So I'm going to define fields here. And again, keeping to the private data hiding concept of data must be hidden and methods must be public, I'll stick to this. So I am going to use a list. The only difference is that this class is what I'll use as my byproduct for further projects, for the classes. So we'll make changes when I get there. Okay, so I do need a list. So I am using a list from the list collection of the API. I will, but as I said, I'll kind of, this is a custom made list. So instead of the generic list from the C# library, I'm creating a custom made, something that my application needs. I'm creating a list. Therefore, I call my class product list, just so that you know. Now, let's learn a few more things. I'm going to create a delegate here. Now, what a delegate is basically a reference to a function. And I'll tell you its use. Give me a little time. Let me kind of put it, since it will be used outside the class. It's just a kind of a, in other words, if that makes more sense to you, it's a new type definition you're doing. So you're creating a user-defined type. like you created product, you've created a user-defined type. So a delegate is a user-defined type. It is a new type that you're defining, but it is a method. It's just not a type. It's just not data. It is a method. And the main use of a delegate in C#, it is used for event handling, but it can be used for other jobs also. But the main use of a delegate in any language that allows it is this. So you define a delegate. The delegate is a method name and a parameter list and the return type. So it's a method signature. The use of a delegate is that if your code contains methods that have the same signature, same return type and same parameters, then you have the option of calling method 1, method 2, method 3, and so on at runtime, depending upon, so suppose you pass a parameter of this type. My parameter is a delegate. Now, when you call that method that has the parameter, you can pass a function name F1 to it, a method named M2 to it, a method named M3, as long as M1, M2, M3 are all of the same type as your delegate. So it gives you that flexibility or that extensibility to call a method, different methods at runtime without using inheritance. Right? So in inheritance, you've done inheritance in Java. In inheritance, what does it allow? You can call methods. A method will be called depending upon whether it belongs to class A, class B, class C, where they are, of course, related by classes or subclasses. A delegate allows you to call various methods in a project, in your classes, by passing the delegate name as a parameter, and the actual parameter that replaces that method name can be M1, M2, M3, as long as M1, M2, M3 match the signatures of your delegate. And that's the power of delegates, right? So at runtime, you say, oh, call it with M1, so that delegate method will be replaced by M1, M1 will be called. At runtime, you pass M2 to it, it will be replaced by M2. I say runtime, it's not static binding, it's runtime binding, because when the program is executed, it looks at the actual arguments being passed and calls that particular method. That's how rich they are. That's their use. Now in C#, their use is more in event handling rather than generic one. But the concept is something that I would like you to get in your head. So how are delegates defined in C#? They're defined with the reserved word delegate. That's how you define a delegate. So a delegate is just a reference to a method. In old languages, we used to call it a pointer to a method or pointer to a function. So all it says is that I can contain the reference of method 1, method 2, method 3, whatever, as long as they match my signatures. So suppose I'm creating a delegate here whose return type is void. I'm giving it some name. I'm calling it change handler because it is going to handle the change. Any change that I do in my list, whether I add a new product, whether I delete a product, whether I modify a product, any change if the list occurs in the list, this delegate will handle it. So I've called it change handler. But that's not its only use. As I said, it's not only in event handling. I'll show you. And it is expecting a object of type product list from you. So in very layman terms, any method that matches the signature of this method, any method that takes a product list parameter and returns void can replace this in a column. That's what it means. So it's like a pointer. So it's saying if you behave, if your signatures match mine, I'm fine. I'll run that method for you. So if you wanted to run M1 and M1 was of this type, of course, with syntax, of course, then I can use it. If M2 has the same signatures, it can replace this method. So wherever I see a method named change handler, I can pass M1, M2, M3 to it as long as M1, M2, M3 all match the signatures of this delegate. So a delegate is basically a reference to a method, if you can draw that picture in your mind. Or it is like it's like a template that can be replaced by any method whose signature matches this signature. That's what it uses. You can pass a delegate in a parameter list, and then when you call that method that you're calling, you can replace this by anything you want. right? So a delegate is basically a reference to a method, or in old languages, we used to call it pointer to a function, because we used to use the word function for methods. That's what a delegate is, right? That's what a delegate is. It's a reference to a method. Now, there are various ways of calling and so on, anonymous methods and so on. I won't go into that much detail. One, because I don't have time, and two, I mean, my aim is just to kind of introduce you to these new things. Of course, if I had more time, I would have done it. Also, another what can I say, member. These are members, right? These are members. Fields are members. Delegate is a member of a class. Another member of a class, which will be new to you today, is the event member. So you know about fields and methods. Those are two members you are very well aware of, right? In any object-oriented programming languages, your class can have fields and your class can have methods. We've also learned that classes can have event handlers because we've been doing forms. But here is something else. A class can also have a delegate. That's another member of a class. A class can also have an event. That's another member of a class in C#. Okay, so I'm creating an event here, and I'm saying that this event is associated with this delegate. So every time when you declare an event, you also have to say with which, like, who will be its event handler. Only in event cases, right? So there is an event and it is associated with this event handler, and the name of the event is, anything you like. I'm calling it changed. So the event is called changed, and its event handler will be a method with those signatures. That's what it means. So the change handler here is a type definition. You're defining a new type called change handler. It's not the name of a method that you can call. Keep that in mind. It's not the name of a method. You're defining, it is just a reference to a method, and it's a type definition. That's what it is, right? So a delegate is a type definition. So this is a new type. So you can kind of think it of as int, decimal. That's what it is. It's a type. It's a type definition. So change handler is the name of a type. What is that type? That type is any method whose signature matches this. The return type is void, and it takes one parameter of type product list, right? That's what it is. And when you declare an event is basically an action that occurs in your program. That's what an event is. That's how you define an event, any action, right? Usually on a form, clicking of a button, selecting something from a list, typing something into a text box. These are all events, okay? So an event, so what I've said here, I've said my event is called changed, and this changed event handler will be something that is of kind change handler. So my event handler will be a method that is of that type. That means it returns void and it takes a parameter of type product list. Till now, till date, when you do your event handlers in any code that you've written, if you look at any code, form design, or like even in save, doesn't really matter. If you notice your event handlers, right? These are your event handlers. Every event handler has a return type of void and takes two parameters, sender and e. And when you write an event like this, if you go and look in the designer file, it has associated this save button click event handler with your save button. And that's what I'm trying to do today. I'm going to write an event handler that will be of that type. So its signatures will be void. The name doesn't matter. And then it will have only one parameter of type product list. And then I will associate the event of clicking of the button with that event handler. So till now, when you've been using these event handlers, you never change their signatures, because in C#, the signatures of an event handler have already been defined. And they're different. When you click on a button, you will see something like maybe sender and event arguments. When you select something from a combo box, it may have a different set of parameters. But the event handlers for all these controls have been defined for you. You never change their signatures. When I say signatures, I don't mean that you can change the name. You can change this name. You can change this name. You can change this name. But you can't change its signatures. There are only two parameters. I'm talking about a button. For different controls, it will be different. And then when you double click on it, what happens is if you go to the designer file, you will notice that the designer file for, what am I looking at? Form new product. The designer file will have, somewhere in its code, it will have that association that the save button is linked with that the save button is linked with my event handler. This is called wiring. That plus equal to that you see is called wiring. So what you've done is you've said that the click event of the save button will be handled by that event handler. Notice how you create an object of that type. So I'll do the same thing. I'll create an object of type new change handler. And then I'll use the same syntax today to associate the event with the event handler. So one of the major uses of delegates in C# is event handler. But that's not the only use. That's not the only use. In other languages, they were just used as pointers. And so it was flexible. Now, since C# we are doing forms and we are doing events, that is one of its use, only one of its small use. Okay. Okay, so having said all that, let me come back to wherever I was. There it is. So I'll show you how to use it. But now you know that your class can have two more members that you hadn't used before, the delegate and an event. Right now, my constructor. So every constructor, if it needs a constructor in which you would like to do something, sure. If you don't want to do anything, then you always have the default constructor. But I definitely need to do something, so I'm going to create a constructor. A constructor has no return type, has the same name as the name of the class, may or may not take any parameters. And this is the default one if it does nothing. But what I'm going to do is I'm going to take my products and create a new list out of it, which you could have done it right here. C# allows you to do the initialization right here. But I always stick to how object-oriented languages should be written. So it is important. You can't work without this. Unless you instantiate your products list, you cannot work with it. Just declaring it at line number 13 or 12, whichever it is, at line number 12 doesn't mean that you've created it. It's only declaration. This is definition. You're defining it now. So you can't do anything with the products till you instantiate the products object, which, as I said, in C# you can do it right here. You can go is equal to new right here. I just don't like how it is done in C#. So I stick to the normal way of doing it in my constructor. That's the use of a constructor. Initializes your instance variables. So I'll stick to that. But C#, Java also allows you, but we never do it in Java because the convention says do it in the constructor. So it's not common to see the equals in Java, but it is quite common in C#, in C++ that you initialize it right there. I'll stick to my own, like my way of doing it in the sense how I like it. So don't forget that you should know how to write these comments now. I didn't pay any attention to them in your midterm because we were writing event handlers. There was not much to write. But when you start writing your own classes, you should know how to write your comments. So in terms of code, you should know how to document your classes. Remember, these are called XML comments. I mean, they generate XML comments. They will generate XML comments though, and they're called XML extensive because you see those angular brackets, that's XML. Okay, so using XML comments. And if you're doing it, keep in mind in my project, I should build itself. There it is. It's already on for me. So a documentation file will be created for me. And how do you create it? You just say yes, and this XML file gets created. All the comments that you're writing in your code here now, where am I? Here, will be converted into XML comments. Okay. Okay. So what is the summary? The constructor creates or instantiates, whatever you would like to say, a list object to store information of products in the inventory. So it's kind of an inventory we are building, okay? So I'm going to use the word inventory. I mean, it depends on what you are doing. That's what the constructor does. It has no parameters, so you don't see any params. It has no return type, so you don't see any return type. So now I found out, like I was doing it in Java, you start with a star and a slash. double slash and star, and it kind of fills it up. Here you first write the definition, and then when you start doing this, it will fill it up for you. So just the way it goes in C#. Okay, so I would like you to know how to write these comments. Again, it will depend. If my time is limited, then I won't ask of it, or maybe I'll only ask it in one file to see that you can do it. Right? So it is all time dependent, but you should know how to do it. Okay, now a few things. A very common operation that you would require on a list is to count how many elements in the list. We already know that there is a count method in the list class, right? So what I will do is I will write a count method in my class because I need it, because I'm now writing a user-defined list, like a custom-defined list for me. So I'll write a count method here, but my count method will do nothing but call the count method of the list class of the library. Okay, so that's how I'm going to reuse the list class. I'm not going to invent my own new methods. Anything that's already available, I'll use it. Then you'll say, what is the whole sense of creating your own list class? Because my list class is customed. I need a delegate, I need an event. So I kind of created my own custom class, and I'm still using the list from the library, right? So you can create custom, that's what you do, you create custom classes. Okay, so now let's write a method here. So since we've learned how to do a few things, if you remember last time, I had told you how to write a self-bodied method where you use the lambda operator. I'm going to do it right here. I'm going to create a public, it will return an int. I'll call it count, I'll still call it count. You could give it a different name if you like. And I'm going to define that method right here using my lambda operator. Oops, using my lambda operator. Right, so I'm going to create a method called count, and all it will do is, we don't use the reserved return word when we use the lambda operator. All it will do is it will use the products, which is a list, and call its count method. I think it's called count. Yes, it is, just to be sure. So what have I done? I've kind of used the count method of the list class to find the count of my own list. And remember, your products is a list product. To begin with, your product is a list product. It's a list. It's a list object. So I can use this. So this count is coming from, notice how it says there, right there. Notice how it says that count gets the number of elements contained in the list of type T. So again, if now you've done classes, pay a little attention to its get. There is a get, but there is no set, because you can never set the value of count in a list object. It's not allowed. So notice how it has a get, but it doesn't have a set. So this is a read-only property of the list class. So this is a read-only property. You can read the value of count, but you cannot change the value of count. Therefore, there is no set method in the count property. Okay, so there is a property called count, and you're just using its get method. Okay, so that's your lambda operator method. Okay, so as I said, whatever I'll need, I'll add it, but I'll just give it a definition that will make sense. Now I'm going to write another member. I'm going to introduce you to another member of a class definition in C#, and it's called an indexer. So that's another member. So like fields and methods, you can have an indexer in a class. Now, what is an indexer of a class? What is an indexer? An indexer, as the name suggests, index, is basically, it's a special method. It has to be written in a special way, and I'll show you what the special way is. All it does, it indexes or gets you the value at a particular index. So I say, get me the 5th element, get me the 4th element, get me the 1st element. I can do that. Or you can say, get me that product whose code is 1, 2, 3, 4. So you can search your list. It searches your list and retrieves the element at a particular position or index, as it is called. Therefore, these members are called indexers. Okay, therefore their name is indexer. Let me show you how you write it. It's syntax. It's kind of syntax bound. That means you have to learn how to write them, but it's not a big deal. Okay, so let's write it. My methods will be public, otherwise they are kind of useless. It is going to return a product object. If I'm going to get something from my list, what is my list? It is a list of product objects. So my return type will be product. Make sense? So the return type is product. How do you write it? How do you write its name? This is how you write it. You say this. So you're basically saying that it will work on the products in this class, right? So you use the reserved word this, and then you say I, where I is an integer. You could use anything. You could use anything, but it is of type int. As I'll show you, it can be of type string also, though int ones are more common because you usually index a list by number. Give me the 0th element, give me the 10th element, and so on. But you can even give a string. So what you're going to write for this member are getters and setters, right? So an indexer is basically a member of a class, and it acts like a property. It allows you, if you decide to, it has a get method and it has a set method. So it's like a property with the getter and setter. The get allows you to get a value, the set allows you to set a value, but again, you can decide. Will I allow a get method? Will I allow a set method? Will it be only a read-only indexer? Will it be only a write-only? Will it be a private set? Will it be a public set? So again, it's up to you. So it is very similar to the properties that you've learned last week. How you write properties of your, instance variables. That's how an indexer is written. So it will have a get and a set. And now what does the get do? Get gets you the element at position I from this list products. That's what it does. Right? You will say, oh, but I can always get it from a list. I can always say there is a get method in the list or some corresponding method in the list. Yeah, there is. But as I said, I'm creating my own custom list. I'll give my own messages. This product is not available, or this, instead of like, I'm just creating a custom list of my own. So again, I will use the list of the original, but I'll make some changes to it. So what I'm going to do is I'm going to do some error handling. Of course, this value of I cannot be less than 0. Why? Because we know that the first element sits at position 0. And this value of I cannot be more than or equal to even. It cannot be more than or equal to the count of your list, because indexes are only from 0 to count minus 1. So I'm going to put, you could write it in different ifs if you want, but I'll throw an exception here. So I'm saying if the value of I is less than or equal to 0, or my mistake, because I'm throwing the exception. I mean, it's just the opposite. Oh, sorry. I'll throw an exception. I'm going to throw an exception and let the user know. Now, you can create your own exceptions. We know that. You do it in Java, you can do it in C# also. But if there is an exception that will make sense from the library, we can use it. So I'm going to use the argument exception. Right? I'll use the argument exception. It already exists. I don't have to bother a lot. Or you can use, there's another one. What was it called? The index out of bounds. Argument out of range or something, right? I can't remember its name, but something like, there it is. It is called out of range. In Java, it's called index out of bounds, and it is called out of range. So you are saying that the I that you give me, if it is out of range, for you, that's out of range. Anything less than 0 and anything greater than count is, or equal to count is out of 0. And you can give your own message, whatever you like. So now you can build your own message, right? Product does not exist, kind of stuff. But here it's just a position you're giving. So you can't say product doesn't exist, because product doesn't exist means the product is not in my inventory. What you're trying to say here is that the position doesn't exist, but it's very kind of odd message to give. So what do you think is a better message that I can give here? Instead of saying out of bounds, I don't know. I mean, here the message saying product doesn't exist is kind of a little odd, but I'll keep it for now. If something better comes to my mind. And you can always show the position also. You can always say a plus I add position or whatever. Maybe I'll do this. At least it makes more sense. No, it won't be I. It will be I minus. If we talk it in terms, if I is 0, I plus 1. So all you are saying is this doesn't exist at this particular price. I don't know why it's giving a get. Because I don't have a return. That's why. Right? That's why it's kind of giving that quickly. So you've made your check. You've said if the I is out of my range, and this is also done when you try to access anything from your list. If you try to say products 15 and 15 doesn't exist, it throws an out of bound exception. By default it does. I've just given it a pretty message. And that's what you do. You make prettier messages, therefore you build your application. Otherwise, what you're going to return is from your products list, add the position I. So see, I'm using the normal I that I would have used if products was a normal list. And it is. It's just that my custom list is going to call it to do the job. So that's what it returns. So you'll say, why did I go through all this? I could have simply done this. But remember, my aim here is to create my own custom class of type list. So it's not extending it, but it has its property. So therefore, I'm saying of type list. Okay, that's what the get method does. So this feature that you are seeing here is called an indexer. This is what it is called, an indexer. And the this here is saying that it is an indexer of this class. So you have to use the reserved word this. You can't give it any other name. The indexer is given the name this. So once you see this, now if you want to, you can go back to the definition in the APIs, in the class libraries to see what are indexers and what are normal methods and what are delegates. Now it will make more sense. Now you'll be able to read the help more up in a better way. Okay. Okay. Now the set method says, oh, you're trying to give me some values. So I'm going to change it at this position. So whatever you give me, I'm going to change it. Remember the reserved word value? We always use the reserved word value, right? So it says, okay, I'm going to, whatever new value you've given me, I'm going to set it for you. But since I have changed my list, I'm going to also do this. You'll say, what is this change? We'll write it, okay? So of course it will give you a red squiggly because you'll say, what is this change? If you remember, unless I didn't write it properly. Yeah, I didn't. I forgot. Events also always start with caps, right? So I have kind of invoked the change event. So it's like in a form, when you click a button, automatically the click event is called. Here I have forced the change event to blow up, not blow up, what should I say? To execute. So I have made this event active. So why am I doing this? Because whenever I make any change to my list, I want to do something in my output. I want to, so you've made a change. I would like to show that change in my output form, in that form where my elements are shown. That's why I've kind of invoked it. So I have invoked, it will say something. Cannot apply indexing to expression of type change handler. Why not? What is this? This is, so what it is saying is, see, I'll tell you what it is trying to say. And I was thinking it's not the other problem. Change is an event. This event is of, it's not of type, but its event handler is of type changed handler, and it needs a product list. Oh, yeah, product list products. So I'm passing it a parameter of type this. Oh, my problem. No. Unless my syntax is wrong. Yeah, my syntax is wrong. It's not square brackets. I have to be very careful with syntax. I'm not as sharp with my syntaxes yet in. So see, keep in mind, why did I pass this to it? It is very important. And what is this? This represents this class. What is your class? Product list, right? Your class is product list. What is expected by this change handler? A parameter of type product list. So when I call changed, whose event handler is change handler, and it is expecting a products list object, what have I passed it? A product list object. Right? So when I say changed, I'm invoking the event. When I invoke the event, its event handler has to do its work. Its event handler says that I need a parameter of type product list. So I passed this to it. And what is this? The current object. And who is the current object? The current object is an object of type product list. So it's all, so therefore it's an advanced topic, right? They're a little advanced, and therefore they come later in the book because forms are really easy. But this is the concept. So as I said, in this example, I am using my delegate as an event handler, but that's not its only use. It's much more richer than that. I wish I could show it to you, but C#, my course is about forms, but Again, I thought I would do this extra work with you. So this is an example of an indexer, another member in a class. Right? So it seems very similar to, why wouldn't I just use products I? But notice I've added few things to it. This I could have, this was not a big deal. Even that one throws an argument exception. So it was okay, I can live with it. But see what I've done here. I have invoked my event, and that when that event invokes, the event handler is called. When that event handler is run, what will happen? We will write that. We haven't written yet. We haven't yet replaced it. I've just given a definition. I've just said this is a delegate. But what event handler will work is what we will have to kind of put in our code, and we will. Okay. Okay. So let's save that. If you're following me, good. If you're not following me, this will be available on GitHub. Sorry. So I've started creating it. I haven't finished it. I mean, it's a long job, but anyway, at the end of the class, it will be ready for you. Hopefully I can make a connection. Oh, okay, I'm good. Sometimes it just doesn't work. Like it just won't push. Anyway, here it is, right? So this is a normal indexer. Useful. You're accessing a product by its position. What I'm going to show you is another more useful indexer. So I'm going to write another indexer for you. It will again return you could return whatever you like, but it will again return you an object of type product. You'll always define product. You'll always define indexers with the reserved word this. You're defining it. And what I'm going to do here is, yes, this is where you have to be careful about syntax. They're square brackets, because indexing is always using square brackets. I'm going to pass it a string, and you can call it whatever. I'm calling it code because it makes more sense to me, that now I'm going to return something to you based on the code you give me. So it's like searching for a particular code in your product list. So you have a list of products, and now you're saying, give me the product whose code is this. Useful method. I mean, it could have been a normal method, get product by code. That's how you do it in Java. You say get product by code, get product by position. You write your get methods. But in C#, I'm now showing you how that method can be written as an indexer. That's the aim, so that you see the new stuff. I don't know. Have you done this with Rich? Not necessarily. So I don't know. As I said, this is more to do with classes. But anyway, nothing goes waste. If you see it today, you'll use it someday. At least you know what it is. Okay. Okay. Now, again, the same getters and setters. And again, you decide, do I or do I not? Will set method make sense here? No. See, it won't make sense here because you're trying to look for a product with a particular code. You can't save a product with a particular code because a product has code, description, and price. So I don't have a set method. As soon as I was writing it, I said it didn't make sense. You don't have to write it. Maybe it doesn't make sense. It's saying get product by code. That's what it is doing. Okay, so what will get do? Right, the get will look for that product with that code, and if it is available, it will give it to you. And if it is not available, we will return a null. Because that's the only way that I can kind of say that it does not exist. Oh no, I'm trying to, I thought it was, anyway, I keep forgetting. Okay, so what will you do? You want to search for this particular product in your list. How do you search for something? Use a for each loop. Or maybe contains method. Now, yeah, contains method. The only thing is now this contains will again cause not issues, but of course we'll have to do more with it because remember your list is a list of objects. If it was only a list of integers, I could say contains 5, contains 10. Now again, I have to do that work. I have to get the product, I have to get the code out of it, match the code, and then if it is contains. So I'm kind of overriding the contains method. It's the same concept that we had when you were sorting a list. If it is a list which has records, I call them records because it's not a single element, then you just can't use the contains method. Okay, so what I'm going to do, I'm going to write a for each loop like you would normally do. Call it P in, it was called products. Right, and if I can find it, if I can match the code, if P dot we'll use a property code. Remember, there was a property called code, which is like a getter. You're getting it. So you don't have a get method, but the property code will get it for you. And I shouldn't be doing it actually. You can use the equals method in strings. Code was a string, but I'll avoid it. Strings in C# can be compared with the two equal to operators. It can be. In C#, not in Java. Objects must always be compared with the equals operator, right? With the equals operator, equals method, sorry. And now, since my code could be a string and it could be case sensitive, do you remember we've done this before? So I'm going to use the equals method, and you'll have to help me because I've forgotten. We did it sometime where you can ignore the the uppercase and so on. If you remember, we've done it. So there is one Boolean. Let's look at the other one. String value. There it is, string comparison, right? And that string comparison had something which said that cases can be ignored. So I'm going to use this one. So I'm going to compare it with the code you've given me and comma string comparison dot. There it is, current culture ignore case. Not bad. So basic, oh, no, I haven't yet finished. Sorry about that. Here and here and here. So I'm doing a comparison of code ignoring case. It's like your equals ignore case in Java. So we've used this before, but I didn't remember it off my head. But as soon as I looked at the overload methods, it helped me. And that's one good big advantage of using IDEs, right? You don't have to remember anything, which is okay. So you're basically saying, now just for your information, just though it is, I wouldn't recommend it at all. Strings in C# can be compared with the equal operator, but all it does is compare contents. There is no ignoring case. There is nothing else. So, but I would always like to ignore case when I'm doing searches on string objects. So I'll use this. So if that is it, you return the value of P. Right? So what are you doing? You've written a kind of a contains, but our contains won't work. What isn't it like? Oh, this is outside the get. That's what it doesn't like. So what are you saying? You're saying if my product is found and you're looking for the product by the code, return it. And if I can't find it, if you can't find it, at least return me none. And that's what you do. You return null. And when you use this method, you can check if null comes back, it was not available, or if it comes back, you have it. And in the indexing one, if the exception is thrown, you are looking for something that doesn't exist. And if the exception is not thrown, that one was also returning you the product. So that's your get method, which is written in a different way using an indexer in C#. So look at the format of the indexers are kind of something you have to remember. The heading is not so different. It is this, and because it is an indexer and indexes are written in square brackets, you're okay. Okay, so that's another example of something that is not available by default in a list. Yes, contains method is available, but this is not only contains, because my list is not. It's a list of objects, and each object has fields in it. So I just can't say, does it contain code? I can't do that. I have to retrieve the code. So I've written my own contains method. So this is like a contains method in your list. Okay. Okay, we'll take a break here. And this is saved and it will go back. And then we'll come back. I have to do a few more things. So I've introduced you to delegates. I've introduced you to events. I've introduced you to indexers. I'll do a couple of more things, overloading of operators, and then we'll change our form. Right? If there are any questions and I can answer them, I'll be most glad to. But again, I'm not saying I'm covering everything. But these are things that I have done before in other languages, and they are new for you. You've not done them in Java. So it's good to know about them. That doesn't mean you know everything about it, but at least you know about them. Okay? Okay, we'll take a break of 20 minutes and then come back. And I'll put this on Blackboard again for you after I'm finished and done. It is going on GitHub as I'm doing it.
You could have just lost 10% for training. I like started off with series right now. I know that they're not like good at the terms of cross between the two. Like it's missing some having yeah. This very good practice. I lost where I started saying 72, it should be 72. Oh yeah. And then like I got perfect on it except for that one. I figured like all of them. But it was like all of them. You didn't fix that one. No. That's like I lost like 0.5% of my grade. Yeah, I lost like 45% of my final grade. I was just joking. Like, it's
That's a question of fucking joke.
yeah, I found the question just a joke, and I could answer whatever I want.
John almost answered like I'm silent, like, you know, just say yes. Say yes. You're glad. And you're glad.
Well, like, if he did it the other way around, everyone would have got it wrong. And like, no, it's just about it. It's like, rather than like, yeah, actually, no, it's all around.
You guys would try these.
Yeah, good. Coming back.
Yeah. The midterms were challenging.
And also, like, it's still good shit.
Just finished, yeah.
Like, I think I might not even, like, have a final project in one class, and maybe I have to do something. Like, I think I might just, like, fucking do a final project. Because,
long to get redirected back to Azure.
Oh, yeah.
It's all gone. Oh well, it's not my fault.
Yeah, you have the same problem.
And then Facebook is just it literally back to Facebook login page to back to Azure. But if you know you run everything completely all Azure sucks. So
Yeah, this is, it's all sugar.
This sounds like a pretty good thing, but if we're considering just have the exam, I have 80. That's like if I get a Saturday, then I'm in finals.
I'm in the same one with you for this class. I fucked up on the last test. Perfect one. So I tried to change
Okay, let's move forward then. Right, so that's an indexer. So I'll write a few more methods. They're not tough, but again, they're just written a little differently, but here they are. So again, self-bodied, single line using lambda operator. So I'm going to write let me not forget public because that's not its default. I'm going to write a fill method. Oops. I'm going to write a fill method. As the name suggests, this method will fill the list with data. So take your products. Oh, no, wait. Let me think. What was fill doing? Yeah, it was filling up the list with. I'm right. And we already have this product DB from last week. If you remember, it was a class that was working with files, and there was and I forget the name, so I have to look it.